Truly leveraging and benefiting from streaming data is hard. The data stack is costly, difficult to use, and still has limitations. Materialize breaks down those barriers with a true cloud-native streaming database, not simply a database that connects to streaming systems. With a Postgres-compatible interface, you can now work with real-time data using ANSI SQL, including the ability to perform multi-way complex joins, which support stream-to-stream, stream-to-table, table-to-table, and more, all in standard SQL. Go to dataengineeringpodcast.com/materialize today and sign up for early access to get started. If you like what you see and want to help make it better, they're hiring. Data and analytics leaders. 2023 is your year to sharpen your leadership skills, refine your strategies, and lead with purpose. Join your peers at Gartner Data and Analytics Summit from March 20th to 22nd in Orlando, Florida, for 3 days of expert guidance, peer networking, and collaboration. Listeners can save $375 off of standard rates with code GartnerDA. Go to dataengineeringpodcast.com/GartnerDA to find out more. Your host is Tobias Macey, and today I'm interviewing Srujan Akula about DataOS, a pre-integrated and managed data platform built by the Modern Data Company. So, Srujan, can you start by introducing yourself?
Hi, Tobias. Thanks for having me on the podcast. Nice to be here. Just by background, I'm the co-founder and CEO of the Modern Data Company. We started this company about 4 years ago, built a product called the Data Operating System, DataOS. And my personal background come from a bachelor's and master's in computer science, started my career off in Motorola, building network infrastructure, then moved to product management, worked in multiple consumer-based, location-based services, startups, building navigation products, maps, did my own startup called Dude, which was a location-based messaging product, led that to an exit. And over the last 8 years, I've kind of transitioned and working more on data platforms, large-scale data platforms, as a head of product at companies like Personagraph and more recently Appsala, where our team built these massive scale platforms used by advertising and marketing teams to drive those efficiencies and kind of become the intelligence hub for marketing. So that's the background I come from. And my co-founder and me, he was the head of engineering. I was the head of product in these data companies that I just mentioned. And we came together to start Modern to solve what we feel is a pretty big gap in how simple data is today. That's the mission with which we started the company, is to solve the data complexity in the modern data stack.
And so in terms of the Modern Data Company itself and what you're building, I'm wondering if you can give a bit of an overview about what it is that your actual mission is and some of the story behind how it got started and why this is the problem that you wanted to spend your time and energy on.
So when we kind of started, we built a data management platform at Appsala. And when we sold those data platforms and the attribution and the analytics raw data into these massive organizations, what we realized is organizations that had full control over their data stack and are able to use that entire ecosystem efficiently got 10x the value from the same product versus organizations that didn't have that level of control over their data stack and the unified approach to data. That is what got us really thinking about, why is that happening? Such a big gap between certain companies on the same product getting significantly higher ROI. And they are able to kind of solve the complexity of data to a certain extent to bring in new data sources, use them a lot more effectively for things like fraud detection and such. And that is where we realize there is a gap. Even though organizations are investing a lot of dollars into data modernization, into the modern data stack, there is still that gap that is not allowing enterprise business users on the enterprise side to work with data. They're not thinking outcome first. They're still very dependent on IT to drive and solve their business problems. So we realize there is a need for an operating system, sort of an architecture that can be layered on top of a customer's existing data infrastructure and allow them to use that data in a lot more simpler manners, both from a data developer perspective and from a business perspective. In a sense, what we did with the DataOS, and for our customers, we go in, we deploy DataOS as a platform, as a service in their environments, and usually in a matter of 4 to 6 weeks, we make their existing data stack work in a modern way and deliver that simplicity that I was talking about.
In terms of the product that you're building, you mentioned that DataOS is kind of the core offering, and I'm wondering if you can talk to what you view as the overarching scope and the goal that you're hoping to achieve by building this and providing it as a service?
So to start with, one of the core goals for us is to provide a unified approach to data in an open standards manner where the customer has full control to extend and bring in the tools of their choice, both from the data management perspective and tools to actually use your data, like the Tableaus, Power BIs, AIML platforms, and such. So that is sort of the core essence of the DataOS. If you think about what we actually deliver, I'd put it in three layers. At the most basic level, we have a data layer, and the value we bring is by deploying DataOS on top of your existing infrastructure. Three things that happen in a fairly automated manner. One, you get a consistent way to access any underlying data. So through a standard SQL interface, our customers can now start accessing everything from CSV files to text files to databases, the lake houses, all types of data systems, including Kafka topics, Pulsar topics. And more recently, we're introducing way to do selects on an API endpoint. So being able to give you one consistent way to access all of this data through a common SQL interface reduces the need to replicate this data, reduces the need to create new pipelines. That's on one side at the most basic level. The second thing we do is the way we've built an attribute-based access control governance engine from the ground up allows our customers to start governing a traditionally non-secure data storage system like an Excel file or an Access DB or an Oracle DB with most modern ways of governing it. For example, you can apply row-level filtering on an Excel data. You can apply encryption, on an Oracle database. Once you're elevating the governance to a modern standard on top of the existing systems, that gives you a lot of flexibility in how you want to use the data. And the third thing at the data layer we do is give you a consistent way to discover this data. So we have a fairly automated data catalog that allows you to do deep searches, advanced searches, Google-like searches across all data sitting in a multi-cloud heterogeneous environment. This, if you think about it, are some of the core principles of a data fabric, providing that level of consistency with respect to discoverability, access, and governance. On top of it, we have a knowledge layer, active metadata management that creates this knowledge graph on top of the existing customer infrastructure. So we spend a lot of time R&D in being able to introspect your existing pipelines, all of the existing tooling that you have, create all of that knowledge into this metadata layer, and we provide an open API, which allows you to leverage all of this metadata that we are collecting across the enterprise and use it to enrich the value of your existing catalogs, existing tools that you already have. And then all of this is a repeatable, reusable architecture. So that's the core essence on the data side. And then on top of it, we introduced a concept of a data lens, which allows business users to define the outcomes that they want, the metrics, the measures that they would like to see from the right-hand side. So define the ideal state of how you want to look at your customer data, how you want to look at orders, even though the orders are coming from 10 different order management systems, for example. And once you do that, we provide a very simple way for business users to ask questions in 2-3 lines without having to write complex SQLs, stored procedures and write the entire pipeline gets automated. And with that, you can now use our tools on the other side to deliver the data as a time series database if you want to do a AIML on top of it. On the same data, we can deliver it as a data cube to run your advanced analytics use cases, reporting use cases. We provide APIs and GraphQL interfaces on top of these data products so that you can build applications on top. And DataOS, in a way, takes care of all the management, deployment, access of the apps. So it's a lot more agile, simple way for businesses to take advantage of all of this productization we did on the data discovery and the knowledge graphing that we do, and use all of that information to start using data themselves without having to constantly depend on IT. So that is the 3 layers, the data layer, the knowledge layer, and the lens layer on top. And then this is surrounded by standard ODBC, JDBC connectors, APIs on the data products, GraphQL interfaces, which enable the business teams to bring in any tools of their choice. So we don't limit you to say everybody in the organization has to use a Tableau or a Power BI. You can bring in tools of your choice. You can bring in query engines of your choice. You can develop your AIML on top of platforms that you would want to, and they all can connect through our standard interfaces. So we want to be that layer that provides that openness and gives customers the freedom of choice to use tools of the choice.
In terms of the kind of composability of what you're building and the integration with existing infrastructure, I'm wondering what are some of the assumptions that you have about kind of the underlying use cases, underlying capabilities for an organization where you're getting engaged, and some of the ways that customers should be thinking about whether the DataOS is an appropriate solution given their existing operations and their technical expertise.
DataOS is being used by our current customers, and we have some large enterprise customers using DataOS today to drive their data modernization. We never rip and replace anything that they already have. So this delivers a value that I said in terms of the simplicity without any disruption to their current stack. We don't want customers to constantly worry about doing integrations and modernization. So we can connect into your existing pipelining tools and extract all of that and graph it out. We provide that layer that allows you to govern all this underlying data in a unified manner, the access that I spoke about. And we've built this platform with such a composable architecture and abstractions at each capability within the unified ecosystem we deliver, which allows us to, for example, if the customer has an Alation as a catalog, we can easily extract the metadata from Alation, enrich our discovery, or vice versa. The knowledge that we build out is available. Every aspect of the DataOS is API driven, and these APIs are available to our customers. So you can start integrating by using these open APIs into your existing stacks, enrich the value without having to replace. So that is one of the big value adds we deliver is you get this modernization without having to disrupt what you're doing today.
On your site, one of the things that you're discussing in the context of this DataOS is the idea of data as software. And I'm wondering if you can talk through some of the principles that make that possible and some of the ways that that manifests in terms of how people are engaging with your platform.
As a general design principle, we are always code first and UI second, right? So every aspect of the data artifact is versioned on the DataOS side, including the data itself is automatically versioned. We provide a lot of declarative tools for our customers to start delivering value without having to get into all the complexity and the boilerplating you'll have to do to just do basic functions. A lot of those things are abstracted out. As an example, the way we do the consistent access discovery and governance through our data depot construct on your existing system, instead of you having to share credentials with your developers, figuring out the key rotations and all of that, as soon as we operationalize a SQL Server, for example, each table becomes a data product with a unique address that we deliver. So when you are creating jobs, when you're trying to manipulate the data, you just call the UDL, like a URL for data within the DataOS context. And the entire security and all of that is automatically taken care of. So a lot of these aspects that we provide, we are very DevOps friendly in how we approach our infrastructure. Is delivered as infrastructure as code, so you can very easily bring up environments. You don't need to create separate dev, prod, instances. You can have different workspaces and namespaces to manage your dev and test environments within the same install. So there's a lot of these typical software engineering practices which will allow the repeatability and reusability of what you do is what we are trying to drive, that way of thinking about data.
In terms of being able to make that code-first approach possible, what are some of the interfaces that you are exposing, some of the programming languages that you're treating as first-class citizens, and how you think about some of the kind of tool selection and the capabilities that you expose versus the things that you try to kind of automate and own internal to the platform?
So we do have, like I said earlier, a very microservices driven architecture where each capability, every aspect of the DataOS is API driven, and our customers have access to those APIs. If you don't like the experiences you see on the DataOS, our customers can create completely new data experiences by leveraging that API layer. We provide a command line interface, very similar to a kubectl sort of an approach to that whole CLI. And there's a lot of dev tooling, sample code, templates written so that you can easily declare, what you want instead of having to write everything from the ground up. So there's a lot of that dev tooling we built. And when it comes to different stacks, we don't want to impose, like we have to use a specific stack. So we, on the DataOS side, have integrated multiple stacks. So for example, for Spark, we kind of created an abstraction around Spark, so you don't have to worry about all the boilerplating, the resource management. All of that is fairly automated by the DataOS side, and the developer can declare what needs to get done. We have separate stacks for streaming data. We have a different stack for complex event processing. We also are integrating the DBT stack. So depending on what the customers would like, the DataOS with the openness of our platform allows you to bring in multiple stacks. And then when you're actually creating your DAGs, the one advantage of a DataOS, the developer experience is you can work with multiple stacks and create the DAG. So you can use our Flare stack to do some of your basic Spark programming. We have a streaming stack called Benthos. We have a stack for your data app deployment and running. And all of these different types of stacks can be connected together into a DAG. So there is that thing as well. And then the other aspect is you can now, as a developer, start accessing data that is stored in any of the different storage systems using a common SQL interface. So all of these capabilities is what facilitates that kind of simplicity and the data as software construct.
You also list that there are 11 key features for the DataOS, and I'm curious what your process was for identifying what are those kind of core capabilities that are a must-have, and what are the pieces that are a nice-to-have, and figuring out what the order of priorities and operations was as you were going from idea to execution and the initial launch of the platform.
So one thing that we constantly encourage our customers to do is start thinking right to left, start thinking from the outcomes, and let technology deliver data against those outcomes versus limiting yourself with what data do I have, right? So define your ideal customer 360. Let DataOS tell you the quality of the data, what data is available today, what is missing, and how to facilitate the right, outcome, right, in the ideal manner. The second thing we wanted to do is give a consistent interface for business teams so nothing breaks on their side. You could add new data sources or change your data, modernize your infrastructure to go to a cloud warehouse or move from Snowflake to Redshift. The business team should always have a consistent way of working with data. And the rate of change that is happening on your data infrastructure should not break anything on the business side. These were some of the core principles, that we wanted to empower. So now if you work backwards from that, we wanted to make sure one thing we noticed is we looked at all the existing data governance stacks, for example, and we realized we wanted to build something ground up to provide the kind of control we wanted to provide. So we built an ABAC-based governance engine from the ground up. We built a workbench capability to provide access through SQL to do a selects on Kafka topics, to API endpoints, to data sources. And that is something that we didn't see exist in the market, so we developed that. We started more recently deploying this concept of a data contract, which essentially is an enforceable SLA between the producer and the consumer of the data. So when somebody is producing data, they know exactly what this is being used for, what sort of trust and quality dimensions are needed to make sure that the business can actually leverage the data that you're producing. So that is something that we are building, from the ground up. So where we saw a gap in the current data ecosystem to provide the kind of simplicity that I spoke about is where we have invested in. The one thing we are very clear about is we do not play in the analytics space. We do not play in the AI ML space. Our goal is to facilitate this simplicity, provide an operating system that can deliver high quality trusted data in any formats the customer needs so that they can bring in the tools of their choice to drive outcomes. So that is sort of how we thought about it. Another thing, a core capability we built is the observability through the entire data lifecycle. That facilitates a lot of efficiencies from a data developer perspective, but at the same time, even business users start leveraging our observability to deliver insights during the actual workflows of our typical user. So one of our customers uses our observability to understand anomalous orders being placed, understand that their customer shopping cart construction has changed, the patterns have changed, and then send the sales team push notifications versus them having to come to a Tableau or a Power BI dashboard to look at that a few weeks later. So those kind of modern experiences is what we are driving. And for those, we built some of the capabilities you see on our website. And then we also, like, for example, data connections. the ingestion piece. For us, it's more commoditized. So, we provide a few basic connectors, but we also integrated Airbyte cluster. We can work with the Fitrans, Alumas of the world, or the cloud native data connector. So that is where we did not invest in. But the core capabilities which we thought are lacking today to deliver the simplicity, we built.
And that's something I wanted to dig into as well, with kind of the modern data stack being the latest meme, the had staying power. And there are some companies who are approaching this challenge of kind of tool sprawl within the modern data stack by packaging all of the other existing tools under a single facade, but under the covers, it's still those separate tools. And I'm wondering what your thoughts were on kind of how to approach the kind of repackaging of existing tech versus building your own capabilities, and at what layer of the stack you were trying to operate, whether it was just kind of this integration piece or if you wanted to be kind of a key element of the stack, or kind of how you think about playing in this broader ecosystem.
From our experience, and a lot of our current customers, they have invested like hundreds of millions in this quote unquote modern data stack and the data modernization. But you're not solving the complexity. Even with the modern data stack, the aspects that I started the conversation with about being able to provide that consistent discovery, governance access, giving business teams full control and empower them to, define outcomes, make sure that the data gets delivered against those outcomes is still lacking. There is that missing layer in the modern data stack that can facilitate all of this, heterogeneous tools that you're bringing together to stitch a modern data stack become interoperable through metadata layer, which is open. So that gives you a way to look at all of that through a single pane, and then provide the value and simplicity from a business user perspective. That is still missing even after organizations have invested in this modernization. Given the heterogeneity of their existing stack, you can't really bring in a third-party governance tool and provide the kind of native centralized governance that we can provide, which gives you a lot of flexibility to even provide 100 different views into an Excel file without making copies, for example, right? So that is where we see a layer missing in the current modern data stack to facilitate this kind of simplicity. And the reason we picked to be that open on our architecture is because even while you are investing in this, there are still some missing pieces. So we can kind of fill those gaps that the customer has with respect to governance or access or discoverability to deliver the value. Some of our customers, they want to use our catalog instead of the existing cataloging tools that they have. So we don't limit that. But we see us as that missing layer that will deliver the simplicity from a business user perspective.
Are you struggling with broken pipelines, stale dashboards, missing data? If this resonates with you, you're not alone. Data engineers struggling with unreliable data need look no further than Monte Carlo, the leading end-to-end data observability platform. Trusted by the teams at Fox, JetBlue, and PagerDuty, Monte Carlo solves the costly problem of broken data pipelines. Monte Carlo monitors and alerts for data issues across your data warehouses, data lakes, dbt models, Airflow jobs, and business intelligence tools, reducing time to detection and resolution from weeks to just minutes. Monte Carlo also gives you a holistic picture of data health with automatic end-to-end lineage from ingestion to the BI layer directly out of the box. Start trusting your data with Monte Carlo today. Go to dataengineeringpodcast.com/Monte Carlo to learn more. Digging into the implementation of the DataOS, I'm wondering if you can talk through some of the technical architecture that you're building and how you think about the kind of composability. What are the pieces that you are confident in, and what are some of the areas that you're continuing to iterate on and evolve as the rest of the ecosystem grows?
To start with, we currently deploy DataOS as a PaaS. So we deploy within the customer subscription. So following an operating system construct, we built a cloud kernel tier at the most basic level, which abstracts out network storage and compute so that we can deploy on any cloud. So we are cloud agnostic. We run on all major clouds in our commercial deployments today. It is delivered. We Terraform the entire install infrastructure as a code, Kubernetes-driven architecture. And that is how we deliver DataOS and install it within a customer's environment. Typically, it takes us half an hour, once the customers provision the VMs that we've requested of them, to then deploy DataOS and have it up and running. So when we started off our first iteration of the DataOS, a lot more tightly coupled data discovery to governance to how some of these components work together. And what we have done now was kind of made them a lot more loosely coupled so that we can bring in other tools of choice. If the customer has an existing catalog, be able to leverage that. If the customer is using an existing pipelining tool, how do we extract all of that metadata? So that is where we went from a tightly coupled architecture to a more loosely coupled architecture. Like I said, there is abstractions built at every layer of the data stack. We start the data OS architecture with a set of primitives like data depots, your policies, some of the governance aspects of how you govern the data. A lot of these are primitives, repeatable and reusable. And the modularity of the architecture allows our customers to, for example, automate the entire profiling of the data through a basic workflow, or you could call our profiling service, point it to an existing data set, and just get the profile report on that specific data set. So that is the nature of the services-driven architecture and the composability of taking different tools that we unified and give you different experiences. So for example, we can realize data fabric design pattern very, very quickly in weeks instead of months and years that it takes our customers, because we have all the building blocks of a data OS, or of a data fabric, and the composability of our architecture allows us to package these things to create data fabric design patterns. We've implemented almost like a CDP design patterns to operationalize C360s, build and operationalize C360s for some of our customers. We are now starting to work with some customers who are leveraging the data OS to roll out a data mesh architecture in their organization. So all of these different patterns can be realized using the components of the data OS, which are composable.
For the workflow for people who are adopting DataOS, I'm wondering if you can talk through some of the process of getting it integrated into their systems, getting it integrated into their workflows, and some of the kind of collaboration aspects about how the workflow transitions between different roles and stakeholders in an organization.
To start off with, once a DataOS is deployed on a customer's cloud environment, we have this construct of a data depot. Think of it as a slightly more functionality than a typical ingress egress that you do with the data integration tool. We elevate the governance. We have the capability to do query pushdowns through our depot construct. We provide universal data links to each data table or a file through the data depot construct, so you don't have to constantly share security credentials. So that kind of gives you that consistent discovery access and governance on top of our depot construct. So when we install, that's the first thing we do is provision these data depots, which usually essentially is an access into these traditional source and sync systems. Once that gets done, there's a fair amount of automation to convert your Excel files, your tables, etc., into data products on top of the data OS and catalog them. We do the schema evolution, we do the dictionary of the data, we can fingerprint and help you understand your classification of data, we profile the data, and a lot of this happens while we keep the data in place. And this now gives you a way to understand, once I process, let's say, your customer database. Now I can tell you, what is the completeness of your emails, what is the cardinality of your, of the SKU field, so on and so forth. So that level of profiling at the most granular column level is automated for you. We extract the lineage information from the source system to where we are, within the data OS, and all of that lineage is available to you in an automated manner. Once you get that level of understanding of the data, the lineage, the provenance, then all these different stacks we make available allow data developers to quickly declare, what they're trying to do. And we do a fair bit of automation of actually creating the job and running it. We provide all of the entire job orchestration on top of the data OS. So that is where the data developers work on the modeling piece. And then the lens construct essentially is where the business users are almost defining, you can call them, digital duplicates, digital twins, where you're defining the metrics, the measures, the attributes that you want to see in an ideal state. We leverage all of this knowledge within the data OS through the knowledge graph, through the catalog, through all multiple aspects, and intelligently map data into those lenses. And once you start querying these lenses, we push down. So you can build a customer 360 lens where you have your clickstream data coming from BigQuery, you have your customer data coming from your Salesforce CRM, you have some other data coming from your SAP Hybris Stack or third parties. And once you construct a lens which takes all of these capabilities and creates a customer 360, the business users start asking questions in 2, 3 lines, almost like an NLP-ish simple English sort of queries. And then we have the intelligence to figure out this query needs to be farmed out into these 4 systems, what joins need to be applied, what transformations need to be applied, and give them the result while we keep data in place. And when you like it, you can operationalize this into any data format, into any type of a data system to you start using it. So that is a typical flow of, where DataOS gets used. So the initial discovery, cataloging, making sure the governance policies are set up is your, data governance, data stewards, data engineers working at that level. And then we have an entire business layer, which the business users work on. So those are the 2 key personas for DataOS.
In terms of the escape hatches or some of the ways that developers and platform operators can address some of the maybe sharp edges or limitations of DataOS, what are some of the ways that you think about being able to kind of add escape hatches to the workflow to say, okay, well, we don't quite have this integration implemented. So if you want to be able to call out to, an API within your Airflow cluster to figure out what the latest task execution time is, then, here's where you drop that snippet of code or something like that.
So like I mentioned earlier, if we don't have data depots for every system, we provide an Airbyte integration to say, hey, we give you a lot more options that way. From a query engine perspective, we provide our own query engine, but you have our standard interfaces where you can plug in Dremio or a Presto or a Databricks Spark SQL, you name it. So we provide a lot of flexibility for the developers to bring these kinds of tools of their choice on top of the DataOS. Every data product within the DataOS has an API layer so that you can start leveraging that data. If you want to build more visual applications, we'll give you GraphQL interfaces on top of it. And then we also have a standard ODBC, JDBC, OData connectors so that you can plug in any tools of your choice. And if you start connecting, for example, your Tableau through our standard ODBC, JDBC connectors, then the governance policies, the granular governance that you're setting up applies there as well. So one tag that you drop on a specific field to change the classification from non-PII to PII, and if you say encrypt it with a SHA-256, that essentially gets applied to all different, from the query engine layer to the reporting to the Jupyter Notebook layer. And that is how we, provide those kind of simple interfaces. And then we also allow customers to build applications on top of the DataOS. So we package DataOS with a few applications on top of it, but our customers are now starting to build applications by leveraging that API layer. And once you build the application, DataOS takes care of the entire management, access controls, deploying, discoverability across the enterprise. So we have an entire, almost like a small app store construct on top. So that gives them the extensibility.
And in terms of that kind of application, the App Store or the application idiom, I'm wondering how you think about that as far as being able to do kind of sharing of business logic or of workflows, both across an organization and then even between organizations.
A lot of that also is driven by the kind of understanding of the context of the data, the semantics, the knowledge around the data, both from a business and an operational perspective. So all of this is captured into our knowledge graph, and we provide Cypher and Gremlin interfaces so that you can start extracting that knowledge and start leveraging it with other systems, as you'd like to. So both the data and the semantics, any DataOS customer owns the entire data and the semantics around the data completely so that they have then open interfaces to leverage that across, value driving tools and data management capabilities.
You mentioned earlier some of the kind of specific elements that you decided, we're not an ML platform, but I'm curious, what are some of the ways that you think about limiting the scope of what you're building so that you can focus on the core value and some of the specific features and capabilities that you're expressly choosing not to try to implement or adopt?
So we always want to see ourselves as an enablement layer, right? We want customers to bring in the right tools of their choice to run better machine learning. If I want to enable my entire data sharing through Snowflake, we can do that. So we believe, there are different products. They have very good strengths for specific outcomes that they drive. So instead of us trying to do everything, give customers that freedom of choice, which is what is limiting them in a lot of ways where, you get logged into a specific vendor or a specific compute or a specific activation cloud, which oftentimes limits those enterprises. So we see ourselves as a layer that'll sit on top of whatever infrastructure you have and provide you the simplicity needed for the customers to bring in the right tools of their choice to essentially get value from data and use the right cloud environments and the right activation clouds to run different workloads. So you might want to run your ML workloads on a GCP versus some of your supply chain workloads on Azure. That kind of control is what DataOS provides to our customers. So we always want to stay within the enablement layer and provide open interfaces for the value delivery piece, which is analytics, machine learning, and so on and so forth.
As far as the design elements of the platform, curious, what are some of the ways that you think about making it approachable and easy to use, and some of the kind of user experience aspects that have been useful and kind of beneficial to you as you're working with some of your customers?
So far, we've been very focused on the data developer persona in making sure we provide multiple stacks, we abstract out a lot of the boilerplating, the complexity, the resource management, so that developers can just declare what they want to do and start using data a lot more efficiently. So that is where we are focused on so far, is that persona. And as we are starting to work with some large enterprise clients, they want that kind of simplicity even from a business persona perspective. So we are now starting to add a lot more of, like I said, we are always code first, UI second. So a lot of things that are done through YAML, that are done through a lot of SQL, etc. We are starting to add simple interfaces for customers to, for example, create their own lenses, right click to say, prepare this data for machine learning without having to go to IT, and the pipeline is automated for you. So that level of UI driven way to empower business teams to do analytics, machine learning, data sharing, and data app building is where we are kind of pushing next to provide that business layer simplicity.
As you have been working with your customers and building the product, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
So we've seen very interesting use cases. So we work with a large architecture firm. We started off initially with an IoT use case where they wanted to understand space flow of the different architectures that they roll out, right? So understand space and optimize space flow for retail, for their commercial clients, etc. So that is where we started off with them. To now we are looking at their HR data and being able to provide a resource 360, like a customer 360, because it's a very services driven business when you're doing architecture. So for them to understand what is the right team composition, which locations should work with each other to deliver this major project, what sort of team construction would make sense based on all the historical data we have. So from providing an IoT use case around spatial analytics and space optimization to now moving towards a resource 360s and HR analytics. And then in between, most of their data analytics team is using DataOS to deliver enterprise reporting on top. So it's very varied in terms of what we are seeing. We are seeing, I can't talk a lot about the details of it, but we just started working with one of the big DoD agencies within the US government. And there are some really interesting use cases around predictive maintenance, around supply chain optimizations, within the DoD space as well. So that we did not expect to happen this quickly. But given the capability, how mature the platform is, versus, and also the governance, that we've set up, allowed us to get into these kind of, organizations as well. So that's something that we've seen. But the one thing where I saw massive, and we didn't think a small feature would have that kind of a business impact, is the observability on top of DataOS that is driving sales operations for one of our customers. So from sales teams which had no idea about what orders were being placed to now getting a level of insight pushed to them, automatically. That has really streamlined the sales operations from a customer perspective. Yeah.
In your experience of building this platform and working with customers and validating it in the market, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I would say, good question there. I think the biggest challenge for us has been, because there's so much of, I'd say, I don't know if you agree with me or not, but a lot of overselling that has happened, in the data space. And every vendor talks about every capability. It looks like everybody has the exact same, product capability when you look at the marketing aspects. So for us to figure out the right way to position this and show, where we fit as a layer on top is something that was quite challenging, especially last year. And now we are able to, clearly show this as that missing layer that is delivering a very crisp business value, both with respect to time to market, with respect to the agility that the business teams are getting. And that took us some time. So that was where we, at least last year, struggled to figure out what is the right way to position, given the amount of noise that's there in the data marketing today.
For people who are interested in being able to kind of simplify their workflows around data on top of some of this modern tooling, what are the cases where DataOS is the wrong choice?
I don't see DataOS, as a wrong choice, because we are working with customers that have a fairly legacy infrastructure with, AS400 DB2s to Excel files to, PDF scans, to companies that have invested in fairly modern tech stacks with the Databricks, Snowflakes, DBTs of the world. And we are able to deliver a similar value in both constructs. And we're talking about, Fortune 500 clients in this context. And we have customers across a wide range of verticals also, from government to logistics to architecture to distribution and retail. And we are seeing that kind of a value across multiple organizations. Just to give you an example, we have a basic framework to create an entity 360 very, very quickly and deploy and operationalize it. So now I'm seeing that being used by retail to operationalize customer 360s. I'm seeing that used by some services organizations to do resource 360. Some of our healthcare clients doing member patient 360s. We built it in such a way that it's a bunch of primitives and the core constructs are the same. It's essentially the data and some of the business logic that changes. And that is where we make that happen fairly quickly and efficiently.
As you continue to build and iterate on DataOS and grow your business, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas that you're excited to explore?
Absolutely. So a couple of things. One, all this metadata that we're able to collect and kind of the nature of the platform as a unified, data ecosystem capability allows us to bring in a true 360 around your data. The metadata around it, the knowledge around the entire or the intelligence around your data. And because we're able to collect that amount of information and we see what is happening on the other side, we are now starting to invest a lot in AI for data so that we can start facilitating a lot more simpler way to work with data. So we are now working on, if the customer declares an outcome, we'll apply AI on top of the metadata that we collect and be able to prescribe what data sets will drive the outcome and what could be the quality of the outcome. Similar to, we're doing a lot more work on clustering of data to show similar data sets. When customers have 20 different ways of naming a customer ID, how are you creating a common, ontology on top of it in a fairly automated manner? We are working on technologies to provide column vectors, table vectors, data vectors, so that you can understand similar data sets and discover them in a lot more simpler manner. So there's a lot of investment being made to leverage AI to provide simplicity on the other side. So we are working on NLP, more powerful NLP interfaces for business users to ask questions on top of DataOS when it comes to data. So that's something that we're doing. But the thing I'm most excited about is what our CTO has been blogging a lot about over the last 3 to 4 months, and seeing a lot of good dialogue within the data leaders across multiple verticals, is this construct of an open data contract, where the business teams can define the contract terms against which they want to see the data. So if you're using your data to do financial reporting, you don't want the data to come from more than one hop from the source system. You might want the data to be fresh as of that hour. The quality has to be about 98%. The governance has to be to a certain standard. These are some of the things that you can now start defining as these data contracts. And when your producers are essentially producing the data, the contracts will enforce the quality and the governance standards and the shaping of the data, so that when the business starts using it, they can trust with full audit compliance logging that the data is at the quality and the trust that they want. This, we believe, will create that handshake in a much more efficient manner and a scalable manner between the data producers and consumers, which today is lacking, I feel, in a lot of organizations, which leads to multiple copies, multiple shadow platforms being created. And we hope this data contract will address that. And we're seeing some really good uptake and efficiencies that this contract construct is driving for our current customers.
Are there any other aspects of the work that you're doing on DataOS and at the Modern Data Company that we didn't discuss yet that you'd like to cover before we close out the show?
No, I think we covered a fair bit of what I would have wanted to talk about, or some of the ways that we are trying to simplify and help organizations get a handle on their data complexity. The thing that we touched upon a little bit is our vision is, instead of customers constantly thinking about technology, start thinking capabilities. Elevate the conversation in the data space where customers start thinking about capabilities that they want to deploy quickly versus thinking, do I need Snowflake? Do I need Redshift? Do I need Azure? Do I need GCP? Things are always at a very technical nature when it comes to data conversations. And we are hoping the App Store construct, some of the simplicity that we want to drive, will allow our customers to productize their expertise and deliver them as capabilities which are repeatable and reusable instead of thinking about everything from scratch, ground up. So that's the vision.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I'd say that handshake that I spoke about earlier, where, the producer of the data, somebody who's working on your Salesforce application has no idea what that data will be used for. A developer that takes that and creates a data model and now adds a new column to that model has no idea what is breaking on the business side. I believe a driver for a lot of complexity today, where you have to repeat pipelines, create multiple copies of data. So that facilitation, I think, will really simplify and give business users the trust and confidence to start using data to drive their outcomes. Of course, it's a very simple statement to make, but it needs a lot of tech behind the scenes with governance, access, things that we spoke about. So that, I believe, is, where there is that gap that I see. And if we can figure out that gap and provide a consistent contract, enforceable, auditable, I think we'll see a lot more, I'd say, agile innovation from a business perspective in using the data.
Well, thank you very much for taking the time today to join me and share the work that you and your team are doing on the DataOS and the ways that you're working to simplify some of the complexity of being able to actually build and share and maintain these data applications. It's definitely a very large problem, so it's great to see people like you taking a stab at providing a tractable solution. So thank you again for your time, and I hope you enjoy the rest of your day.
Thank you, Tobias, for inviting me. Great conversation. Thank you. Have a good rest of the day as well.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.